Hello, Math 1, Shasta High School. This is Mr. Roberts. Question 94 asks us to basically take two different points and fit those points so they go through an exponential function. So that's key right there, the fact that it says exponential. And it says an exponential function of this particular form. And if we take a look at what we have here, we have a couple points, right? We've got an x point and we've got a y point. For each of these 2 points. For this point, we have an x coordinate and a y coordinate. And for the second point, we also have an x and a y coordinate. So what I'm going to attempt to do is to write essentially a system of equations, a system of exponential functions, and solve for a and b, because I know x and y twice on this particular curve. So I'm going to write the function y, except I know a y value. So let's go ahead and use the first point. So if I'm using this let's use the second point first. So I'm going to use this point, and that will give me, if I use that y value, 30.375, and that's a decimal point, and that equals a times b raised to the 5th power. So you can see what I've done is I've taken the x and y from this point, and I've plugged them into this exponential form. Let's do the same thing with the second point, right? So I'm going to bring it down. So this equation, based on the, what's the first point listed here, but it's the second one I'm using, would be 13.5, because that's its y value. And again, I'm copying down its y value. And that equals a times b, and this time x is 3, so raised to the 3rd power. Now for each of these, what I'm going to do is I'm going to rewrite them so that a is by itself. So I'm going to isolate a. So that's pretty simple, right? All I have to do is, in the first instance, I'm going to divide both sides by b to the 5th power. If you were to look at, for example, a times blah, right? A times something. If I want to get a isolated, and this is a simple equation, I would divide both sides by that value. So I'm dividing both sides by 3. The reason why I divide by that 3 is because it turns out that a number divided by the same value it cancels out. So in this case, we're going to divide both sides by b to the 5th power. So this becomes 30.375, and if I divide that side by b to the 5th, I get over b to the 5th power. And on the other side, I've got, well, you can see what it is, right? It's a. Right now, it's a times b to the 5th, and I'm going to divide that by b to the 5th. And you can see here the reason why we're doing this, right? If I divide both sides, I divide both the numerator. If I divide the right-hand side by b to the 5th power, I now have 5 factors of b in both, and they completely cancel out. So that ends up just leaving with just plain old a. I know what a is. Let's do the same thing for the second equation, and you can see we're going to be dividing by b to the 3rd this time to isolate my a. So I end up with 13.5, and that's going to be divided by b to the 3rd, and that again equals a. At this point, what we have is we have 2 different ways of writing what a is. A is 2 different things. A is either 30.375 over b to the 5th, and a is 13.5 divided by b to the 3rd. So we're going to use substitution. We're going to take this value of a, because this is a, and we're going to plug it into the other equation. So if you look at this bottom equation, I'm going to just go ahead and rewrite it. So my left-hand side is 13.5 divided by b to the 3rd, and that it will equal. Now instead of writing a, I'm going to write what a is from the top equation. A is equivalent to 30.375 divided by b to the 5th. And we could do that not because of magic, but because these are equivalent to each other. So I'm replacing something that's equal to a. So moving forward now, I want to get, I need to solve this. And one of the things that I like to do whenever I see fractions is figure out how I can clear those fractions. And it turns out for this particular, it is a proportion, right? But I can multiply both sides by b to the fifth power. So I put parentheses around here indicating that I'm going to multiply both the left and the right hand side by b to the fifth. When I multiply the left hand side by b to the fifth power, we can think about this. What I end up getting is, and it might help if I write this, right? B to the fifth over 1. So you can see both the numerator and denominator that I'm multiplying by. When I do that on the left-hand side, we get 13.5 times, and I'll put it here, times b to the fifth, that's my numerator, and my denominator is b to the third. Now, when I simplify this, you can see that I have got 5 factors of b in the numerator, and I've got exactly 3 factors of b in my denominator. So these cancel, and I'm left with just 2 factors of b in the numerator. And of course, the shortcut way of doing that is because the bases are both b. 5 minus 3 is 2, so that shouldn't be surprising me that it is that. So this is equivalent to just plain old 13.5 times b squared. And on the other side, the right-hand side, you can see I have I'm going to be multiplying by b to the fifth over 1. So I'll give me exactly 5 factors of b in my numerator, and I already have 5 factors of b in my denominator. So that's just going to simplify to 30.375. Now if I divide both sides by 13.5, I get b squared equals 30.375 divided by 13.5. And then to figure out what b is, we're going to take the square root of both sides of that. That will give me both the positive and the negative root there, but because of this setting, I'm going to be using just the positive one. So let me grab my calculator. Oops. And with it up and running here, I need to clear this screen. So let's take a look at this. We are going to take 30.375, so 30.375. Oops. And I'm going to divide that by 13.5. And I get 2.25. And what I need now is the square root of that. I'm going to take the root of both sides. If I take the square root of that, I get this root of 2.25. That's fabulous. It gives me exactly 1.5. So let's make sure we understand our thinking before we move on here. I'm taking the square root of both sides of this. I'm taking the square root of this side and the square root of this side. This number on my calculator equals the square root of the right hand side. So this number is just 1. This whole thing now is just 1.5. And on the other side, if I take the square root of b squared, it's essentially the absolute value of b. So it could be b could have either been positive or negative, right? But we typically will write this plus or minus on the other side. So b is equal to plus or minus 1.5. And in this setting, we're just going to be using the positive root. We're going to use positive 1.5. Okay, so I now know what b is, right? B is exactly 1.5. Now what I need to figure out is, well, what's a? So if we look at this, I have 2 ways of figuring out what a are, right? They're here. These are both descriptions of a. And I could use either one of those, right? I could use either the top one or the bottom one. And it's going to allow me to figure out what a is because I already know what b is. So let's go ahead and use the bottom one here. So I'm going to take this expression. Oops, let me grab the black pen. Which is, you can see the bottom one is 13.5. So I have 13.5 divided by, I just erased what b, there's b, divided by b to the third power. B we have found is 1.5, and we're going to raise that to the third power. So let's evaluate that expression. moving the calculator back over here. So I'm going to take 13.5, and I'm going to divide that by, open parentheses, 1 point, oops, I missed the 1.5, and I'm going to raise that to the third power. So when I do that, I get that this is the expression for A is equal to 4. And I would have found that out with either one of those top expressions. They both would have given me that A is 4. So this is 4. So I now know that A is 4, and I know that B is 1.5. So if I'm taking a look at this, I'm ready to write my equation. My equation is going to look like, and I just was peeking up here to see that form at the top. It's going to look like, it's ugly. It's going to look like y equals a times b to the x power. So y, which is the variable, a variable, right? Y equals, I know what a is. I'm starting at 4, and this has a multiplier of 1.5. Actually, that means it's increasing by 50%, and then to the x power. So this should be my exponential function that would contain both of those points. Now again, for any equation to contain 2 points, that means that it has to be true when you plug those points in. And if I feel a little insecure and nervous about this answer, I certainly can take my calculator and I can evaluate these two expressions. So for example, if I take if I use the first one, x was 3. If I put in x is 3 into this and multiply 4 times 1.5 to the third power, it will give me, that's exactly right, 13.5. That's what it should have done. And the same thing with the second point. If I take 4 times 1.5, that's a 4. 4 times 1.5 to the fifth power, that should give me exactly 30.375, and it does. So this is doing a good job of hitting exactly those 2 points, and it's an exponential function.